Here's a question that often separates beginners from true practitioners in data science interviews. Can you explain the ROC curve and AUC, and what they tell you about a model? Let's make this simple and intuitive. The ROC curve, or Receiver Operating Characteristic Curve, shows how well your classification model distinguishes between classes. In other words, how good it is at separating positives from negatives. It does this by plotting true positive rate on one axis and false positive rate on the other, across every possible threshold your model could use to decide what's positive. Now, instead of focusing on just one threshold, the AUC, or area under the curve, summarizes that entire curve into a single number, ranging from 0 to 1. Think of it like this. A model with 50% AUC is no better than flipping a coin. 100% AUC means the model perfectly separates all positives and negatives. And in the real world, something around 85% AUC is considered solid performance. So, in one line, here's how to frame it in an interview. The ROC curve shows how a model performs across different thresholds, and the AUC gives me a single score that measures how well the model separates the two classes. That's exactly how you'd explain it. Clear, confident, and human. So now the interviewer might follow up with, okay, that's clear, but why does AUC matter, and when should you use it? Here's the key insight. ROC and AUC are threshold independent, which means they evaluate your model's performance across all classification thresholds, not just one fixed cutoff. This makes them extremely valuable, especially when your data or business context changes the threshold for what counts as a positive. Let's talk about the advantages. First, they handle class imbalance better than accuracy. Even if you have far more negatives than positives, AUC still gives a meaningful sense of how well your model ranks the true positives higher than the false ones. Second, they give a comprehensive view, showing how trade-offs evolve between catching more true positives and accidentally including more false positives. And third, they're easy to compare. You can look at two models and instantly tell which one discriminates better between classes. Now, here's what a great candidate says in an interview. If Model A has an AUC of 0.92 and Model B has 0.86, it means Model A is better at ranking positives higher than negatives across thresholds. It's not just about one score. It tells me Model A will perform more reliably, even if I adjust my decision threshold later. That's a thoughtful, real-world answer. It shows you're not just quoting metrics, you understand why they matter for model reliability.